In the last video, we introduced the kinematics variables. In this video, we will see some important relationships between them. Let's start by reviewing the three variables of kinematics. Displacement, that's delta x. That's the vector change in position. Velocity, that's v, the vector rate of change of position over time. And acceleration, that's a, the vector rate of change of velocity over time. In this course, we will examine situations where acceleration is constant. There are many such situations in both the natural and the engineered world. In these cases, the kinematics variables can be interrelated in different ways. I've always called these interrelationships Newton's Toolbox Equations, so that is how we will refer to them in this video and beyond. Say we have an object like a car that is accelerating. If you take two photos of it at two different points in time, you'll see it has physically moved and its velocity has changed. We can therefore talk about several quantities relevant to the car: its displacement, its initial and final velocities, its acceleration, and the time that elapsed between the photos. Start with the definition of acceleration. If we rearrange this slightly, we get my favorite way of writing the first of Newton's toolbox equations. Acceleration times time equals final velocity minus initial velocity. This should make sense. It just says that the change in velocity, that is, final minus initial, equals acceleration times time. Notice that the t has no exponent. That makes this equation a disguised version of a linear equation with respect to time. A second relationship comes from performing a technique from calculus called the antiderivative. I won't go through the derivation, but it leads to this relationship between displacement, initial velocity, acceleration, and time. The displacement equals initial velocity times time plus 1/2 acceleration times time squared. Here we see t raised to the second power. This equation is a disguised form of a quadratic equation. A third relationship stems from rewriting the definition of velocity. My favorite way of writing this third equation is like this. Displacement over time equals initial velocity plus final velocity over 2. This should also make sense. It just says that displacement over time equals average velocity. The fourth toolbox equation is formed by algebraically combining the above equations and substituting out time. Final velocity squared minus initial velocity squared equals 2 times acceleration times displacement. These, then, are Newton's toolbox equations. They can be applied to any situation where acceleration is constant. If acceleration is not constant, these equations don't apply, and we would need calculus to find relationships between the various quantities. Remember, there are overall 5 variables that are involved in these equations. You'll notice that each of these equations contains 4 variables. No two of them share the exact same 4. They're all in different combinations, which means each one is used in a different context. Each one is used when different pieces of information are available. This video has introduced Newton's toolbox equations. In the next video, we will see examples of how to use them.